Hi, welcome to Bookie. Today we will unlock for you the book The Structure of Scientific Revolutions by Thomas S. Kuhn. Our understanding of science begins with the textbooks from our school days. In these books, the scientific world is presented as a pearl necklace composed of a series of scientific events. Each event is like a pearl on the necklace. Scientists are a group of people who contribute to collecting the empirical facts, establishing theories and methods of a particular scientific field, like a pearl master. Proponents of this view of the history of science believe that the development of science is linear and cumulative, just like climbing slowly up a stable and reliable slope. But Kuhn believed that some authoritative books, including textbooks and popular science books, actually mislead us. In the real history of scientific development, it is often difficult to precisely define when a scientific event occurs and who the first person is that has discovered a specific scientific event. Science does not develop through the accumulation of discoveries and inventions of famous individual scientists in the way that we imagine. This book argues that the route of scientific development appears as multiple independent development curves, showing nonlinear and revolutionary features. Since its publication in 1962, this book has not only started a cognitive revolution in the philosophy of science, but has also profoundly impacted the fields of sociology, cultural anthropology, art history, and political history, and further penetrated the popular culture. The author Thomas S. Kuhn presented us with the common features of scientific progress, accurately described the process of scientific development using the concept of transformations of the paradigms, and profoundly interpreted the nature of scientific revolutions. In fact, scientific revolutions do not only concern the accumulation and progression of knowledge, but also a whole set of changes in world views and methodologies. Therefore, the structure of scientific revolutions is publicly recognized as a watershed in the history of the philosophy of science. Thomas S. Kuhn was an American physicist and historian of science, and was considered the most influential philosopher of science after Karl Popper. After receiving his doctorate in physics in 1949, Kuhn worked at Harvard University, University of California, Berkeley, Princeton University, and Massachusetts Institute of Technology. Apart from this book, Kuhn also authored books such as The Copernican Revolution, The Essential Tension, and Black Body Theory and the Quantum Discontinuity. In this Bookie, we will summarize the key content of this book in 3 parts. First, what are the features and patterns of scientific development? Second, how does science progress? Third, what is the nature of scientific revolutions? Let's now look at the first part. What are the features and patterns of scientific development? As mentioned earlier, Kuhn believes that scientific development occurs in a leapfrogging manner rather than continuous and cumulative as many think. The reason why we misunderstand the features of scientific progress is due to the influence of textbooks. Textbooks only record the aftermath of scientific revolutions, while disguising the process that leads toward the scientific revolutions. With intentional or unintentional deletion and emphasis in textbooks, scientific development is presented as a single, steady, and continuous process. For example, we may think that Newtonian mechanics arose through appropriate adjustments and development of Aristotelian mechanics. And after further adjustments and development, Newtonian mechanics produced Einstein's general theory of relativity. The discipline of mechanics seems to have a clear developmental goal and route from the beginning. And other scientists just add bricks to the building along this development curve. But the reality is that Aristotelian physics, Newtonian physics, and Einsteinian physics used completely different research methods. These 3 theoretical systems are like 3 different curves. They developed independently along different curve trajectories with different life cycles. This book points out that the appearance of the latter curve sometimes seems to be born from the former, and sometimes appears to arise out of nowhere. Either way, it shows a characteristic of occurring in a leapfrogging manner with hints of being revolutionary.